equations with absolute values. So first we're going to look at solving equations, and then we're going to look at writing equations in the next video. So equations with absolute value. When we think about absolute value, we're talking about how far a number is from zero. So we use these symbols here, these two vertical lines, to represent absolute value. And if I have the absolute value of a number, and I tell you that that's D, then D could be either 10 or D could have been negative 10. So before I absolute valued it, which is not really a verb, before I absolute valued it, it might have been positive or it might have been negative. So there's two situations here. First case is that the expression inside the absolute value symbol is positive or zero. The second case is that the expression inside the absolute value symbol is negative. So either of those things could have been true before I absolute valued it. I'm not sure which means that there's possibly more than one solution for our variable. I think this is the first time we've ever really looked at there's more than one possible solution for an equation. So let's look at how we solve those. So we're going to solve and graph these absolute value equations. You'll see your absolute value symbols in there right off the bat. So we've got the absolute value of 2x minus 1 is equal to 7. So we want to get the absolute value expression all by itself on one side of the equation, and then it's equal to a constant. And then we're going to split up into two equations from there to utilize our absolute values. So I'm going to split this into one equation where 2x minus 1, this is the expression inside the absolute value symbols, that's equal to 7. Or what was inside the absolute value symbols, 2x minus 1, it could also have been negative 7 before I absolute valued it. So I'm using the 7, but then I'm also using its opposite of a negative 7. So from here I have two equations. I need to solve both of them. Once I solve my first one, I get x equals 4. I solve my second equation, I get x equals negative 3. So what does that mean? I'm going to highly encourage you to check your answers to absolute value equations, because there are weird circumstances, which we'll look at, where things get a little bit odd. So let's check our absolute value solutions before we assume that we're good to go. So I'm going to plug my 4 into my original equation, and I come up with 7 equals 7. Excellent. I'm going to plug my negative 3 in there. Negative 3 times 2 is negative 6. Negative 6 minus 1 is negative 7. Absolute value of negative 7 is 7. Great. So I have two solutions that absolutely work. I've checked them. My two solutions are negative 3, 4. Notice I'm putting them in, this is set notation. We're looking at a solution set here. So I'm going to use those brackets. We also want to graph it. So on my number line, I have the numbers negative 3 and 4, and I've got dots on there. You can put all the numbers in the middle there if you want. If you want to do the minimalist version of the graph here, that's fine too. Let's look at two other cases of absolute value equations. So we have the absolute value of b plus 7 equals negative 5. So again, my absolute value expression is by itself on one side of the equation. So I'm going to split this up. And I'm going to say what's inside the absolute value symbols could have been negative 5 before I started, or it could have been positive 5 before I started. I'm going to use the opposite of that expression that's over on the right. When I solve for this, I end up with b equals negative 12. I also end up with b equals negative 2. Again, please check them. You don't have to write it out, but use mental math and check them to make sure that they make sense. So when I plug negative 12 in here, negative 12 plus 7 is negative 5, and the absolute value of negative 5 is 5. That's not equal to negative 5 at all. All right, let's try the other one. Negative 2. Maybe this one will work. Negative 2 plus 7 is positive 5. The absolute value of positive 5 is 5. That's not equal to negative 5 either. What is going on here? Let's go back and think about what this original expression is asking us for. It's telling us to take an expression and find its absolute value. Absolute value is always a distance from 0. We never talk about it as distance as a negative, so there's no possible way I can have an absolute value that is negative. So if you notice this off the bat, great. Can you avoid some of the work? Absolutely. But if you just get on autopilot and go through it, your check is going to catch you for that. So for this one, there's no solution. There isn't any number that I can put in here to come up with its absolute value of a negative. That doesn't work. All right, one more with an equation that has a few more pieces to it. So I have the absolute value of 2x plus 3, and then outside the absolute value symbols, minus 4 equals 1. So notice on the left here, there's absolute value, but we also have some other operations going on. We need to get rid of those first before we can split this up into two equations to find the value of the expression inside the absolute value symbols. So I need to get rid of this plus 4 first. So I just subtract 4, very straightforward. I subtract 4. Now I've got my 2x plus 3 equals 5, very nice. I can split this up into two equations. I end up with x equals 1 and x equals negative 4 for those two solutions. I air my brackets, negative 4 and 1. We were graphing these, so on my number line I have negative 4 and positive 1 as my two solutions. Again, I highly recommend you check these, so let's go back. 2 times negative 4 is negative 8. Negative 8 plus 3 is 5. Yes, negative 8 plus 3, negative 5. Absolute value of that is 5. 5 minus 4 is 1. That checks out. Let's try the negative 4. Negative 4 times 2 is negative 8. Did I just try? Oh, I did the negative 4 already. Sorry. Let's try the 1. Put the 1 in there. 2 times 1 is 2, plus the 3 gives me 5. Absolute value of 5 is 5, minus that 4 also gives me 1. So both of these check out, just doing mental math. Those are my solutions. I'm done.